Alright, we're going to go ahead and look at solving systems of linear equations by substitution. I think I got it so that the first part comes second on accident, so it'll talk about what these solutions mean graphically, the three different conditions. So we're looking at two equations here. 4x plus 3y equals negative 13, and negative x plus y is equal to 5. So the idea of substitution is solving one of the equations, usually for either the x or the y, and it just depends on usually what looks the easiest to solve for would be my recommendation. The first equation has 4x and a 3y, so the numbers are not incredibly nice in the terms of getting whole numbers, so I would probably want to use that second equation with the negative x plus y is equal to 5. If we just add x to both sides, then we have y equals x plus 5, and that's exactly what we'll do here. I'm going to call them equations 1 and 2 in case I want to refer to them later on. So if we solve that second equation for y, we have y equals x plus 5. And we're going to go ahead and substitute that into equation 1, so replacing the y with an x plus 5. And from here we're going to go ahead and distribute that 3 through, so we'll have a 3x plus 15. And we'll go ahead and solve this by subtracting 15 from both sides and combining the 4x and the 3x. So that gives us 7x plus 15 equals negative 13. We'll subtract 15 from both sides and get 7x is equal to negative 28. And then we'll divide both sides by 7 to get negative 4 for our x value. Now at this point in time, you've solved for one of your variables, and it doesn't matter which one you substitute in. You can substitute into equation 1 or equation 2 to find the other variable. I would go with what looks like the easiest. The path of least resistance is what I would choose. So I'm looking at that second equation, negative x plus y equals 5 might be a little bit easier. So I'm going to go ahead and write that down. Negative x plus y equals 5. And what we're going to do is we're going to replace the x with a negative 4. A negative sign came with the formula, so you're going to have negative 4, so you need to be careful about that. Plus the y, and that's equal to 5. So negative makes a positive. Positive 4 plus y is equal to 5. And we end up getting our second solution, y is equal to 1. So now I went ahead and drew an arrow just to kind of give you kind of a flow of this. Tried to separate my work here with boxes to kind of make it a little bit cleaner looking. Now what I want to do is I want to check. If you want to be extra safe, check in both solutions at the end. However, since we found one of our answers and we substituted into the second equation, for the most part you'll be okay if you just check in the equation that you didn't substitute in. So we didn't substitute in equation 1, so we'll go ahead and just check equation 1. So that was the 4x plus 3y, and that was equal to negative 13. So we're going to go ahead and plug in what our x is, what our y was, and see if that is equal to negative 13. So we get negative 16 plus 3. And oh, it is negative 13, so we've done this correctly. So we're going to go ahead and give ourselves a check mark and a smiley face because we've done it correctly. Now, when we're writing our answer, we're going to go ahead and I'm going to call it a point of intersection because that's where the two lines intersect. And we can abbreviate that and just call it POI. And that's just about all we got to do here. So point of intersection, or POI, as I have trouble spelling intersection, it looks like. So POI, and then it's x comma y, so negative 4 and comma 1.